Okay, good morning. It's an honor for me to stand here in the Turing room. I will just dive in because we don't have a lot of time and it's a completely new language. So I hope to do that in 45 minutes. So it's a challenge not only for me, but also for you. So be nice to me. Nelumbo is a meta-language, means it's a language for defining languages, and itself is also a language based on logic reasoning as a semantical underpinning of the language. So that's it. It has its origin in a lot of real-life projects in the Dutch Text Office and in healthcare formalization of clinical knowledge, which means complex knowledge formalization in a purely declarative way, so that you get no overspecification and domain experts are directly involved in artifacts that at the end up in software instead of all kind of steps in between. So the idea is that you can model logic in your domain-specific language using Nelumbo. Fully declarative, direct support of predicate logic, strongly typed. It's performant because of the fact that it doesn't reason over the extent, all instances of a type, but it only navigates relations. I will explain that all. It's extendable with your own semantical and syntactical atoms in your language. And it will have full editor support in any EDA using the language server protocol. Okay, so first of all, in Nelumbo you can define syntaxes. And syntaxes exist of types, meaning actually the non-terminals of your syntax, and patterns. And here you see a bunch of examples of those patterns, pattern definition actually. So here we have a literal, a number, and that represents in this language an integer type. But we also have addition and minus and a Fibonacci function defined here. So this is purely syntactical. If you define this, and these things are precedents, by the way. So this whole, if you define this, it's immediately available for you to define semantics and to do querying and testing. So there's no compiler or whatever, it's directly usable in the row after it, if you understand what I mean. I will demo that. And you will see that we also have repetition, option, and alternation. So this means that we have eBNF in its full extent, or Beckett's and House format, if people know. And in the Chomsky hierarchy, we are somewhere in context sensitive, actually. So it's even more than context free, if you understand what I mean by that. Okay, semantics. We need variables for that. This is very easy. You just create a name of a certain type, and that can be a placeholder of whatever in the syntax. And the semantics is you try to resolve these variables to primitive literals and to find which resolvements are true and which are false. And this is a definition, for example, for if A is smaller or equal to B, well, this is a very simple specification of its semantics. So now, and this is absolute A definition of absolute, and this is a recursive definition of descendant using child and descendant itself and extensional qualifier. Yeah. All make sense? The extensional qualifier. So it's a predicate logic. So you mean have for all and exist. And so there exists a y for which it's a descendant of x and z is a child of y. So there are two ways of defining that. The whole idea, in contrast with Prolog, you just define it in any way you like, and it will run. Yeah? So there's no order, there's no imperative semantics whatsoever to this language. And in Prolog, you have imperative semantics, actually. Okay? So how you create a query? Oh, sorry, wrong button. A query, well, this is a query, and this is a logic language, so you don't need to have the variable only at the end or something like that. It will just try to find A, and this is a result. It says, well, I found one truth, namely A is 10. There are no more other truths, and probably there are many false bindings, but I won't find it for you because it's not efficient. Yeah? So it will give you, and you can actually negate this, and then the two will flip, if you understand. And if you negate it again, the two will flip again. So that means that not, in contrast with Prolog, is just naturally supported. However, not all results will give an answer. Will find a specific binding of your variable which is true. And you can add logic, you can add rules, you can add facts to fix that. Okay, so these are other results. Here you see an example where A can be minus 10 and A and 10, of course. And here is a proof of addition using a relation of addition. And you see that there is some variable binding here. Here it's A. The rule is projected on A, but actually defined in C. This is the real result of C, and it's mapped to A again. And you can create a complete tree of the derivation in your result, so that you also have to prove how it is derived from the rules and the facts that you have created. Native semantics. So, again. I've defined add over here and created a Java class. Nelumbo is implemented in Java that implements that relation of add, where these are the two addendums, and this is the sum of the add. And then I won't go into the code, but you have to try to find a solution as much as possible, false and facts in your implementation of bindings of those variables, if you can. Yeah? And then the rest of it is generic reasoning. And in this way, you can also connect a database or something like that to retrieve your facts, to name something. So you can integrate it in any area. A question?
Yeah, in this question, let me give a microphone to people online listening. Who had the question?
Is it on? Okay. In the previous slide, there is this add org modeling value Nelumbo integers add, and I would like to know what this is for.
Well, it's a name of a class, a Java class, which has a method, exactly this method that you see over here. So it's a way
infer or what? Because the Java code says infer result.
Sorry?
It's not saying add, or is add the class? Add is the class. Okay.
So this is the syntactical specification. So this is how it looks in your language. And for each instance in your language of this specification, it creates an instance of this class. And of course, the add class needs to extend node. And have a certain constructor. And within it, you can define the semantics or normalizations or whatever you like. So you can also do things like, what is an integer? Well, it's a big integer. Or you can implement a rationale, infinite precision calculator in it, or that kind of stuff. Whatever you like, or database connection.
So infer is just one predefined method that you can use to do things.
Yeah.
Okay.
So you override it. So this is really native in relation to Nelumbo. So it's just Java underneath, and you can create these kind of atoms and build up of your language. Okay. Another example, this is a Fibonacci noteworthy here is the if, which means that this rule, this applies if n is lower or equal to 1, and this applies when n is greater than 1. So actually, this is an implication over this B implication. So each rule is a B implication or a B conditional rule. It's not like prologue. So all facts and all falsehoods are preserved in the rule. You understand what I mean? It's symmetrically defined. Well, and here you see queries and results. And this is quite a big result. And what you see that you can do a Fibonacci of hundreds of thousands and wait a couple of minutes, and you have a number that is bigger than the stars in the universe. Literals. So just some things. You can define directly literals, which are just constructs in your language, like a male, Hendrik, Bernard, Klaus, Willem. Females, Wilhelmina, Juliana, Beatrix, and which we already see a number which is implemented in, again, a native class integer over here. You can create functions. So these are not predicates because they don't have a predicate as a type, but they have an integer as a type. So if you want to define the semantics of a function, then you use the equals because identity is standardly part of your logic. So it's predicate, logic, including identity, which works with unification for the people that are interested in that. So in this way, you project the function on your relation over here. So I only need one relation, add, to define subtraction. This is generally the way you do semantic specifications. Relations and facts. You can also define relations, and for relations you can define facts. So individual facts. Klaus is the parent of Willem. So that's all the facts over that relations need to be consistent with the rules that are about that relation. So it's not in addition, oring, if you like, as in prologue, but the rules need to be aligned with it. And that gives the possibility to later on actually give reactive semantics to this language, because then we just alter the facts according to the rules. A question?
So that hash 30 is priority, you said.
Yes.
How are they determined?
How they determine?
How do you determine that I mean, why 30?
Well, you need to know the other ones.
Yeah.
In comparison in your language to
but you have to specifically say yourself.
Yeah. So you have to know as a language designer, not as a user, of course, but as a language designer, you have to know which languages you extend. And then within that extension, you define what the priority is relative to the priority of the other things that are defined. Yeah. If you define a pattern that is in conflict, which leads to a non-deterministic parse, then you get an error at the point that you define the pattern. Well, and this is an easy predicate. We already see the definition of the semantics of a predicate can be done like this. So, 3 major operators: defining the type, defining the pattern, and defining a rule. And the rest is actually library, including logic reasoning. It's just a library in it. Okay. I will sit here for a demo. So this is a kind of demo editing, live Nelumbo editing. And I prepared some examples. And there will be a repetition of what I already explained, but then with some live examples, just to get a picture. So first we're going to introduce a bunch of variables of the type integer. Yeah? We need that for defining semantics and defining queries. So then I can define actually a query, like this. and it will just immediately, so if I make a mistake in terms of a language, then it doesn't interpret it, because only something that is well formed can be semantically defined. And if I resolve it, it will immediately execute it, the query. Yeah. So that's.
This caught my eye on your very first slide. There are many values for which that expression is not true.
Exactly.
Well, how do you know to stop at a equals 4? Or
yeah. So it's a good question. So why does Nelumbo stop reasoning when there are probably infinite answers to the question?
Yes.
So, well, the idea is as follows. Nelumbo only resolves variables by navigating relations. So not all the integers, but only the integers that can be found, for example, in this case, over addition. And if you want to resolve one variable over addition, two others need to be already resolved. Yeah. And the atomic implementation of addition that you just saw in Java will just respond to the fact that A will have infinite amount of resolvements that are not true, and one resolvement that is true. That's the whole idea of Nelumbo. So it's completely different than Prolog. So if your atoms are freely returning incomplete results. So it reasons just about that. There's no, the variable A is only binds because 3 and 7 are given.
so
It's the answer, but we need to talk more about that, because otherwise we.
yeah, no, I'm sorry to be taking your time.
Yeah.
So you're rearranging that and doing subtraction to get the answer. You're not. You're not.
It's exactly how I defined the semantics early on of subtraction. You saw that kind of sheets before.
Okay. Thank you.
And how it works.
Thank you.
So, yeah. So it's more a constraint solver in that sense than a reasoning engine in terms of a SAT solver or something like that. Yeah. And the constraint solving is always taking place over navigatable relations, and that's why it performs. But that's also why it doesn't know all the answers. So that's the balance that we needed for performance on one hand and expressibility on the other hand in the domains that I work with. Okay, so now I actually put the result here, and it means it's a prediction of the outcome. So if I change it, it says, well, I have an expected result, which is not the actual result, which means that I can assert certain things that I want to be preserved by the rules in the specification itself and write tests, if you like. So it's query and testing by putting well, let's just put some examples here. And this could be a little bit exotic. What you see over here, there are no variables, which means it's either true or false. And there are no variable bindings, so if I want to be consistently having a result, it means that I have an empty parenthesis on the left side, if it's true, and an empty parenthesis on the right side, if it's false. Yeah. Of course, I can create syntactical sugar and say this is true and false or something like that, but that's just syntactical sugar for the underlying inference result. So for example, over here, this is false. Yeah. And we don't know this. So this is probably an answer to your question. This is too difficult to solve. I don't know either facts nor falsehoods that I can derive, because there are infinite facts and falsehoods for this as a resolvement.
So how should I read those 2 dots?
2 dots, oh, that means that I'm not complete.
Okay.
So I know that and in this case, it's even not 1 given, but I know that there are, but I don't know which one. Yeah, and it can also be a combination. I know these ones, but probably there are more. And then I can combine other rules which are certain on the other side, and then combine it over B implication, because unknown can be combined with something which is known by another. So that's so it's a kind of pre-state logic. People, so it's reasoning including uncertainty. Okay, now here we have a nice example that actually gives two resolvements of the same thing. And now I want to address, I want to add something to the syntax. So I'm creating a syntax aspect, the semantics of it, and a query in one go. Yeah? So this is a increment, if you like. Yeah? So this will give an integer that is 1 higher than on the right side. This is the intention of it. So I need to define that as semantics. And since it's a function, I need to use equals for that, because on the left side it should be a predicate, which is either false or true, and not an integer. And here I say that this is just using addition, what the result is. So if I do a query here, then I have the result. So keep in mind that Nelumbo immediately introduced this syntactical aspect and can be parsed. There's no parsing, compiling, or whatever. It's immediately there. And it's actually quite fast. Okay, how many times? Oh, we have a lot of time. Or is that correct?
I have a question. Sorry. So considering that your syntax is dynamically extensible,
yep.
And the fact that for context-free languages or beyond ambiguity, the problem of ambiguity is undecidable. Mm-hmm. How do you deal with introducing new constructs that potentially render existing expressions ambiguous?
Okay. That's a good question. I'm not sure whether I can find the right terminology to explain it. So I need to, in contrast with this audience, do a little bit of imperative intuition here. So underneath is a kind of recursive state machine, if that makes sense. So state machines with iteration, which can go back to a previous state. And then each rule is actually a state machine on its own, and it's merged in the existing state machine. And when, for some reason, that ends into a conflict, it will give you the conflict immediately over there. And if it's in the state machine, it's hash-based table parsing directly. So what that implies for your question is not really it's difficult to answer, because things like the notion of the Chomsky hierarchy are all based on some way of defining syntaxes, and this is a kind of different way of defining it, and I'm not completely sure where the mapping actually takes place, because I can de-ambiguous, if that is a word, some of those definitions by putting something behind it. So it's at the last point where it actually knows what it is. It's not left recursive, it's just recursive. There is a prot parser, a typed prot parser underneath this. It's a precedent-directed parser technology. So it's a combination of typing and prot and recursive state machine merge technology that's underneath. Now I told you far too much about the underlying technology. Another question.
Oh, sure.
Thanks. I'm not from this crowd, so apologies in advance if my question is too obvious, perhaps. But by exploring what are the possible answers, we could also use this kind of mechanisms to include imaginary numbers,
Yeah.
right?
Yeah, it would be a possibility, but the idea is that the primitive relations that you give are open, and the reasoning on top of that is orthogonal to that. So yes, that's absolutely a possibility to use imaginary numbers. So you can create a language for quantum mechanics if you like here, or your own slang in whatever kind of whatever domain-specific language that you like. And by the way, if you, for example, enumerate some type, then of course it can answer it. But it depends on how you define the relations that you have defined underneath, whether it knows whether it's an enumerated type and can efficiently resolve it to variables.
I'm afraid the level of your presentation for my background is rather on an abstract level, let's say so.
Yeah.
You mentioned at the very beginning that you can use this, for instance, in the domain of text rules.
Yeah.
Could you give an example of how you would do this? You'd use this in an environment.
I will do it now, because it's just very simple, but it gives you an idea. But I won't give you text law here, but I show you how more, because the text law at the text is actually defined in structured natural language. So it's a subset of Dutch, which is one way interpretable. And I will show you a little bit how you can do some language design like that in Nelumbo. But I need some time to prepare it. So first I'm going to introduce the concept of friends. And this is a very strict definition of friend. A friend of A, if B and A are friends, then B has A as friend and A has B as friend. And if B has another friend, then it's also a friend of A. So it's a kind of recursive transitive closure of friendship, if you like. Which make you either completely alone or connected to the rest of the world or something like that. So probably I'm a friend of Trump. I don't know. So would also imply actually that cyclic rules are actually resolved. So it's not only recursive, it's cyclic rules even, because it knows the resolvement of it and it reuses it until some kind of fixed point is reached. So and this is crucial for things like in text law, to do to things. So who are you living with, or what are the partners of this organization? Is it trustful or not? So these kind of things can be cyclic and that kind of things, and you have to give an answer to that. Okay, so this is just friends in a more or less mathematical way. And now we're going to introduce some syntax. Here it is. So we know what it semantically means. And here we're going to introduce some Dutch or English actually. Yeah, very simple, but just to get an idea how you can extend the syntax. There's a predicate that said person is person, because I want to write is instead of the equals, because that's how we do that in English. And then a function, person, a friend of a person. So, and then I can introduce some persons, A, B, and who. So I can write what is the meaning of A is B? It is A equals B. And a friend of A is the thing that we already defined on top of that. And then I can just ask, who is the friend of Piet? Who is Jan? Who is Klaas? Etc. etc. So you're completely free in that syntax, and you will have all the parser technology at your fingertips to do these kind of things. The things that we are missing, and actually on the to-do list, is that we also want to define syntactical sugar for rules and patterns. So on top of that, you can create your own attribute language, for example, by defining an attribute with a certain type for a certain class, and then you just create all the language patterns that you expect by introducing that attribute, like dot attribute name, or assignability. So you can create rules that actually assign a function and then define that in terms of a bunch of semantic rules. So that's the next step, where we have completely freedom to define any textual syntax on top of this logic engine. I'm out of time. Is that correct or not? Oh, okay. Let's just do another example, just for the fun. So here we have the Fibonacci. This one I showed in the presentation. Well, it's straightforward, isn't it? This is not correct, of course, because this is not a query and it's not a fact. Do you understand what I mean? So I need to do the question mark. So, and here you see the result within a couple of milliseconds. And there are, it's not 1,000 rules, it's 10,000 rules that I executed meanwhile. And there is a kind of implicit linear programming underneath, if you understand what I mean. So it works with a dynamic memoization so that the left or the right side of the plus of the Fibonacci is not calculated over and over again, because otherwise it would not be polynomial. Yeah.
How's that number to be read? 36 hash?
Read?
I mean, how do I interpret that number? F equals 36 hash 18 NRV.
Oh, sorry, it's because the number is that big,
Yeah.
it won't fit my memory if I do it decimal. So it's 36 characters here, from A to, including 0 to 9 to Z, which is the maximum of what can be. So if a number is found in the underlying, but that's again just library, yeah. So this is the integer library. I can show the integer library. If a number is higher than some threshold, it will render it in some rendering that is readable, and it can both read and write it. Because
Base 36.
Sorry, this is the base.
It's a base 36 number.
Yeah, it's a base 36. Yeah.
That's the answer I was.
So if I put what is it, 16 there, and then you have hexadecimal and what.
So it's the base.
Yeah,
Now
yeah.
I understand.
Yeah. It's just, because otherwise it will take most of the time to actually render the output if you are lucky. But it actually checks it also, so it also reads it. So any base can be used for a number representation. Okay. Now we're on to this, and we have some time left. This is Nelumbo itself, defined in itself, apart from some things that are needed for the bootstrap. You understand what I mean? So we have true, false, unknown, not, and, or, existential qualifier, universal qualifier, equals, not equals. And then some of the things are actually also semantically defined. So if there are two literals, which means the nodes are actually resolved to a non-terminal value. Oh, sorry, to a terminal value. Then it's equals to the equals that I have there, and that's unification equals. And L1 and F1, it just flips the two if it's a function, and not equal is the same as not equal.
Why do you need the two rules for equality?
So this is actually a little bit underneath, but that's why it's the generic library. So you see that there are literals, functions, and nodes over there. And if you do a query, it actually needs to, you ask for literals resolvements of the variables. And the first rule says, if it's a literal, then equals apply. And the second rule said, if left is a literal and the right is a function, then I need to normalize it in the other way around, because that's how I define the semantics of my functions, as I saw earlier. And no, the latter is trivial, I think. Yep. And you see that all these things like Boolean, not, and, or, existential universal quantifier and equals are defined natively in Nelumbo itself. If we go to integers, then I have introduced the type integer over there. It's a number, so that's also a native one, which has its big integer. But again, this is just a library. You can write your own if you like. Add, multiplication, and all the trivial stuff. And then you see the absolute, but then with a nice syntax. And here you have some semantical specifications of the things that are defined. So this is actually what we just used in the example.
I like how you define division as just being multiplication
Exactly.
in a different way.
Yeah, so that's what I say. If it's a relation, I say, well, actually, if it's a predicate again and not a function, then it's a relation between three things. And within that relation, and it's natively defined, you decide when you can actually resolve the variables that you get in combination with the literals that you get. So the reasoning engine will always give literals as an input for that inference rule. So that's already covered. So that you can just naively calculate results based on terminals. The non-terminals are already resolved before calling the native invariance rule. So that makes it very easy actually to implement it. Okay. Here are some logic tests. This is a local variable, A, because it's a quantifier, which means that you won't see it over there. Because on the outside, you don't know, because there could be many bindings, but that doesn't mean that there are many truths for your query. It's either true or not true, if it's only a local variable. If it has other variables, which are not locally, so not on the left side declared as being the things that you quantify about, it will give bindings for everywhere where there is some A found or none or a false, whatever. Yeah. So that's how it works. And the rest is just plumbing to do some major simple tests on the underlying logic. Okay, let's switch back to the presentation. Plans. Namespaces, because I don't know if you noticed it, but I can use the integer library in my mockup editor. But I didn't declare it at the beginning that I want to use integers. Of course, that's cheating. So we need to extend the language so that you can import languages, but also can create local patterns, functors patterns that can be used for defining your semantics, but are not exposed in the language. Or to create a DSL, a domain-specific language, that does not export the underlying language that it uses for defining its semantics. So you have what you call an external DSL in DSL terminology, or an internal, or so you can do internal or external DSLs. Well, that's my expertise, so I don't know whether it's common terminology here. Generics, because we want to do lists and sets, and perhaps even functions as literals. Language pattern transformation, that's what I thought about. I want to have language patterns on top of rules, on top of pattern specification, so you can have complete freedom of any way that you want to expose this language to the world. Language Server Protocol, which is a standard originally created by Microsoft, but now open available. And there are thousands of implementations of different languages, and all big EDAs, including EDAs for the web, support the language server. And that does things like coloring, command completion, debugging, etc. All and more than I just showed in the demo live demo application. Reactive update execution semantics. So actually altering the facts will cause other facts to change so that everything that you define is true. Yeah? So it's a kind of backwards interpretation of it. And so that you can also define GUIs or simulations of behavior in it. Deprecation and migration, meaning that some language construct by evolving your DSL can be obsolete and replaced by more sophisticated ones. And then you can deprecate some for backwards compatibility and immediately give, how do you say that? A refactoring or a change of your syntax. You just say, well, I want to go to version that, and then it will rewrite all your rules the other way around according to the new syntax and remove all the deprecated ones. So this way you can evolve your syntax, which is very important in DSL development in my experience. Okay. Last slide. It's open source. I like any kind of response on this in any form. So you can email me. You can try to implement it, but it's not really easy to just implement it. So we're going to create some kind of website where you can actually play with Nelumbo as an early entrance, but we don't have it yet. We are busy creating it. But this is the GitHub URL, and this is my mail address. So if you like to be involved in what kind of manner, we are searching for people that are writing papers with us about this, try to actually falsify our engine and logic and holes in it so that we can have a really very proven base for the Nelumbo implementation. So, thank you.
Thank you very much, Wim. Is there anybody who wants to ask one more question?
I think in the back, I had an open question for a longer time.
He was first.
No, you were first? Okay. No, I thought.
Oh, it's just a quick question.
No.
How does this compare with other reasoning engines like OWL? You know, property, it has spikes, therefore it's a hedgehog in a class, that kind of reasoning, those type of reasoning engines?
I don't know.
Okay.
I mean, there will probably be some overlap, but the important thing is B implication, uncertainty, and symmetric knot is something that is not, I didn't find it in any, so they're all based on a kind of prologue-like semantics. And this is different, gives you much better performance, but not always a result. So that's how it's fine.
Hello. Many thanks for this very interesting talk that blew me away completely. Surprised positively. And my question is, so the double square brackets at the end, when I saw false and true,
Yep.
and then the false was always the empty set in the first one. The true one was always
The
the
left
empty set.
and the false on the right.
Is that coming from the lambda calculus? Because it reminds me of the lambda calculus.
Well, actually, the syntax that I've created, I created a lot of examples, and then I asked GPT-5, what does this mean? And when I was having more correct answers, I choose that syntax. Yeah, so for creative processes, ChatGPT is marvelous. For logic reason, it's a hell. Yeah? So you need Nelumbo for that.
One last question from the chat. The name, Nelumbo.
Nelumbo. Nelumbo, you know the lotus?
Yeah.
Beautiful flower. If you take the seed of a lotus, then you can preserve it if it's dry for 1,000 years. If you put it in the ground, it will flower. If it's moistured. And Nelumbo is the group of lotuses, because you have lotuses in the south of America and in Asia. And Nelumbo is the common group of those two. That's the origin of the name.
Thanks very much, Wim.